Okay,
let's go over one of these. Which one would you like to do?
Three. People in 80s.
No.
4.
Wait.
What is 4?
But nothing's happening right now.
I'm sorry.
Okay, well, we want
You're saying 4?
We want 4.
So, of the people that have their hands raised, it's kind of split between 3 and 4.
Let's do both. Let's do 3.
Okay.
Oh, both?
We can do both here. Okay, so we need to figure out where secant is negative and cosecant is positive. Where is secant negative?
Quadrant 2
Oh, that makes sense.
And
quadrant 3.
of these two, where is cosecant positive?
Quadrant 2.
Quadrant 2 is our answer. For number 4, it says name the quadrant that this angle lies. Well, this can be simplified to what?
5. -5.
Okay, so this is going to lie on some axis. -5 pi would be 1, 2, 3, 4, 5. Right there. So if it lies on the axis, it's a quadrantal angle, and that's all you would say. But also the axis it lies on.
So what is just one number with a pi? It's just how many times you go around?
Other questions on those two? Make sure your name is on your answer sheet and pass up your answer sheet. For the next 15 minutes, I want you working and practicing on your homework, and then after that, it will be homework. So, we've talked about solving trig equations, evaluating and graphing inverse functions, trig functions, using those inverse trig functions with applications. This piece of it is using our identities and solving and evaluating. So when this gets really complex, remember that that's your goal, to solve or evaluate. And we need to remember a couple things about identities. I know we talked about these when we were learning our unit circle, and we're going to keep bringing these back. Remember that your quotient identities are tangent equals sine over cosine, and cotangent equals cosine over sine. And then your reciprocals are whatever your trig function is equals 1 over the reciprocal. So with number 1, if we were looking for the cosine of this and we're given secant, what's the relationship between these two? They're reciprocal. So to find cosine, I would flip this. All of these need to be rationalized answers and simplified answers. So if you could simplify the square root of 30, you would need to do that. I don't think you can. So in this case, my simplified answer would be negative root 30 over 10. Would be my cosine value of whatever said angle is. I don't know what that is, but if I knew that angle, this would be the exact value of that angle. ones. For 2, we have tangent, cosine, and we need to find sine. What is their relationship?
Sine over cosine.
Sine over cosine equals tangent. So we could put what we know in for those and solve. So root 2 over 4 equals sine of x over negative 2 root 2 over 3. Well, we have fractions within fractions, so before we do anything else, let's simplify that by multiplying by its reciprocal. So that my denominator completely goes away. And I'm left with root 2 over 4 equals negative 3 sine x over 2 root 2, sorry. Now right now I have a square root in the denominator, but I haven't solved for sine, so don't worry about that at this point. Not right now. We will. Not right now. How could we solve this? Yes, we could do that. Can't you cancel the root 2? We could not do that because they're not multiplying. But we could cross multiply because they are just 2 fractions, even though there's a bunch of other things going on.
Wait, question.
Yes.
We can't cancel out the root 2's.
Not right now because they're not multiplying.
So now that we changed it to multiplying, can we cancel it out?
I'm going to write it out first and then it will simplify itself out, yes. So the 2 root 2's are going to come together and make root 4, which is just 2. So if you canceled them out, you wouldn't have 2 times 2, which is what you need. From this point, you could just solve for the sine of x. So somewhere on the unit circle at some angle, it would give us the exact value of negative 1/3. Negative 1/3. And you could check this. Because you know that tangent equals sine over cosine. So if you put sine back into your equation and multiply by the reciprocal to negative 1/3, you should get root 2 over 4. Now, I'm not going to do that because I have in my own notes, but you should be doing that to check yourself.
Did I say 5 elements?
No elements.
What is the sign? This is sign, right? Right there. Yeah. Okay. Yeah.
That's a sign.
Yeah. I'm sorry. It just looked like, yeah, it just looked like Ellen, so I threw it out. I was like, why is that?
No, it is connected.
So,
Before we jump into this one, I want to go back up to our quotients. And we're going to manipulate it a little bit. By using our reciprocals. Because I know that sine equals 1 over cosecant. And if sine wasn't there, it'd be 1 over cosine, which is the same thing as secant. So I could rewrite tangent as secant over cosecant. And then cotangent would then be cosecant over secant, being the reciprocal. But you could use that same logic. Cosine is 1 over secant, and 1 over sine is cosecant. So now that we know that, we could look at this and say we have a cosecant, we have cotangent, we need to find secant, and we can use this instead of switching everything so that it becomes cosine and sine, which you could still do. You should still get the same answer, it's just more work. Secant over cosine. That's beta, just so you all know. That symbol is going to change. You'll see alpha soon, which kind of looks like a fishtail. I'm going to set this up. I don't know if we'll have time to work it through. I did the opposite, sorry. Just like in the last one where we tried to get this out of a fraction within a fraction, do the same thing. I'm going to multiply by the reciprocal. So that I get negative 2 root 10 over 3 equals 7 over 3 secant beta. Except I forgot the secant. And then still cross multiply.
How do you know where the negative goes?
For where?
For negative 2.
Oh, it doesn't matter. You can put it in the top and the bottom. For this, because you're solving it, it doesn't matter. If you were trying to find like x over r, that would matter, but that's not what we're doing. And then from here, you would just solve. So I'm going to write this like this for 1 second, because it needs to be simplified and rationalized. So simplified and then rationalized.
Can you go angle to where? Just like a little bit right there.
So at some angle on the unit on the circle, secant would be negative 7 root 10 over 20. So Tuesday you'll have some time to practice this, and then we'll continue further. Make sure you do that homework.